Okay, I hope you've had a good understanding of what one-way ANOVA is, independent sample t-test, and independent sample t-test, one-way ANOVA are both inferential statistics. And the next bit that I'm going to cover is something called correlation. And correlation is also inferential. What we're doing is we're trying to get data from the sample and infer about the population. Now, what does your PowerPoint slide show about correlation? Okay, correlation does not mean causation. And I like the example here. For example, no matter how highly correlated the rooster's crow is to the rising of the sun, the rooster does not cause the sun to rise. All right, this is a very, simple analysis of correlation in terms of the logical side of things. The relationship between two variables may be apparent but not real. Now, what I want you to understand is there is a high correlation between teachers' salaries and liquor consumption. It is because of the influence of the third variable, such as growth of national income, but not necessarily so. All right. Now, these are some examples. Now, let me see if I can take you to the PowerPoint examples here. All right. And see if I can show you in terms of correlation and what they are. All right. Now, one of the things about correlation you must understand is, and let's see if I can take you to our SPSS slides now. Okay, this is our data file. Now, what I want to do for correlation is I'm going to look at a correlation between two variables. And again, we go to analyze, correlate, and go bivariate. And when you talk about correlation, you can only do correlation amongst interval scale and interval scale, ratio and ratio, or interval and ratio. Never do anything in terms of ordinal or nominal, because that is clearly a blatant mistake. Never correlate anything in terms of nominal, because nominals are only categorical, and in terms of ordinal they can also follow into a certain pattern, and you cannot actually do any form of correlation that way. So here we're going to look in terms of ratio, age, and whether, say, household income. Is there any correlations between people's age and their household income? So all we do is just go, put these two variables, go OK. Now what is it telling me here? It's telling me, first I look at the stars. It says yes, there are two stars. And what it says here, literally at a 0.00 level, there is a strong correlation between the age of a person and their household income. All right, that means the older they are, the higher their income. Okay, now let me take you to your PowerPoint slide. Look at this PowerPoint slide. Sorry about this. All right, now if you look at this PowerPoint slide, it's telling you, it's giving you an output. And if you look at this output here, all right, what is it saying here? In terms of this output, it's showing you a correlation between job satisfaction and a few variables. But what we had in our example was only two variables. So what I want you to look at is more something like this. Here we're talking about overall satisfaction and in terms of total website quality. So what does this show you here? There is a 0.848 Pearson correlation. Now what does this tell you? Is there a high correlation, low correlation, or medium? If you take to the next slide, it tells you. Now, if you look at the readings and they're between 0 and 0.2 in terms of these readings we're talking about here, then there's no correlation at all. However, if it's between 0.21 and 0.4 is a very weak correlation. 0.41 and 0.6 is weak, and 0.6 and 8 is moderate, and 0.81 and 1 is strong. So what was it in our earlier case here? It's 0.848 and it's a sigtail of 000. So what does it tell you? There is a very strong correlation between overall satisfaction and total website quality for this particular PowerPoint slide that you have a look at. All right. So now you've seen this. Let's go back to our SPSS output and let's do a few more correlations. All right, you've seen this correlation here. It's 0.494 compared to, if you look at the PowerPoint slide, it's only weak. Now let's see if we can go to another one here. Go correlate, bivariate, And let's take out maybe age in years and put it back here and see in terms of years at current address. Let's go OK. It's around the same 0.467. All right. So it's not very strong, but there is a correlation. What is it saying in terms of, and again, correlation can be either positive or negative. All right. Positive means as one value increases, the other value would increase. Whereas negative is there's an inverse relationship. As one goes up, the other would go down. All right. Now, let's see if I can take this off here. And maybe let's put, say, debt to income ratio. Go OK. This is very interesting. What is this here? Number one, we look at this SIG2 tail. SIG2 tail is 0.234. So automatically we say there is no correlation because there is no statistically significant correlation at all. And number two, it is negative. So, but we cannot take it any further. The fact that if it's above 0.05, full stop, no correlation. That's it. All right. So you may want to test the hypothesis in terms of correlation, and you may see this appearing, and then automatically you stop and say, although we hypothesize that there was a correlation between these two variables, it's clearly the case where there is no correlation at all. All right. And again, what we have to look at as marketers, what is the marketing implication of correlation? That means if one increases, the other increases if there is a positive correlation, whereas the reverse. So you got to look at the variables and see if there is a relationship. Then let's say a relationship between advertising and sales. So if you have run a correlation, you find there's a direct relationship and it's positively significant, then you can say, now listen, the more money on advertising we spend, the higher the sales. So what would you recommend? You would recommend that we need to spend a bit more money on advertising. Or if you see a negative, then you can actually say so accordingly. All right. So what we have seen now, if I just put a recap all the different sessions, we have seen a variety of different things in terms of statistics, right from basic data entry to in terms of actual inferential statistics. And we have seen all these things, and this is where I want you to make sure that you go back and play these tapes or these particular sessions and see how you understand them. And the other thing I want you to do is also, read your textbook and see the examples there, because that would give you a better idea of how to use these things. Because I think if you look at the chapters in Zygmunt, they tell you all these things about correlation, one-way ANOVA, independent samples, t-test. And things are not, I'm sure you've not found this statistics bit as difficult as you probably proposed for it to be earlier. But I can tell you this much. Having done this, you will find that, it is so much easier to carry on.